Hello, it must be now around about 10 years since these LED lamps first started coming out, and they came out with the promise of up to 50,000 hours of life, but unfortunately that's certainly not my experience. I don't know about you, but I seem to be changing them nearly as often as I used to have to change the old incandescents, which are now practically unobtainable. They were horribly inefficient. The compact fluorescents were somewhat better, but LEDs should be very much better, but I have serious doubts because of their lifetime. If you consider the carbon impact, the environmental impact of manufacture and of disposal, given their unreliability, I sometimes wonder whether they're actually any better than the incandescents were. Anyway, I've got a whole bunch of them which have failed over the last few years, and I've been meaning to tear them down and see what I can find out about any common modes of failure. To start off with, I've got 3 here. I've got another 4 on my desk. I've got 2 of these G4 discs, which I used for a desk lamp. I've also got one of these GU10 240 volt bulbs. These are 12 volts. Now I've taken these 3 apart and tried to analyse what's wrong with them, and in this little video I'm going to show you my conclusions, and I also want to show you how I've actually analysed them, so that you can maybe take apart a few of yours and see what conclusions you come to. In theory, one ought to be able to repair some of these, but obviously ones like this GU10, it was pretty much a destructive process taking it apart, as you can see. Okay, so what equipment did I use in order to test these? Let's clear those away for the moment. So first of all, you need a test meter. This is the one that I've got. They're not expensive. In fact, some of the cheapest ones you can get on eBay are perfectly adequate. You'll need the diode range. Pretty much all of them have that, and resistance ranges. This one is very good in that it has a beeping function to indicate continuity. So that's the most important thing. I also have got one of these little component analyzers, which I got. They're incredibly cheap and very good value at about only about a tenner from Far Eastern sources. I think if you search for GM, what is it, 528, 328, something like that, you'll find examples of these, sometimes as kit form, sometimes as fully assembled, and these will test capacitors, inductors, resistors, transistors, all sorts of things. Very useful to have. Its accuracy, I don't know, but it gives you certainly gives you a good go, no-go indication. Then finally, a little thing that I made up a year or 2 ago, a little LED tester. All it consists of is a USB plug, which I can plug into a power bank, and I can plug an LED into there, or I can take some crop clips or test leads and attach them to there in order to test an LED. We'll be using that in a little while. Okay, so let's come back to this GU10. This was quite tricky to get apart. Here we are. The hardest part was removing the glass face panel. It was like that. And I tried, first of all, running a knife around the edge. Let me show you if I can find my penknife. Here we are. Running a knife around the edge, around there, and that only succeeded in breaking the glass. So I tried some of this Loctite Detach glue remover. This, according to the contents, contains heterocyclic ketone. Don't ask me what a heterocyclic ketone is, but I can tell you it's jolly good for releasing all sorts of kinds of glue. I got it years ago when I thought it might be useful to have something in with which I could unglue my fingers if I ever stuck them together with super glue. Never actually happened. But anyway, I ran a little of that around the edge here, let it soak in, and then very gradually I was able to scrape away some of the glue, and eventually it came away with not too much other glass breaking. So that got into it. The other end, which was a bit trickier, well, not really, but the pins there were actually in the glass, and I thought to myself, if you look very carefully, you can see that the wire is crimped in there. So I thought if I took a pair of cutters and chopped it off there, I'd be able to take the works out. That didn't work. All that happened was that the glass broke, but nevertheless I got it out. Then inside here was this little aluminium reflector, and in there was this little thing of the LEDs, and underneath it was this little controller board. Very simple. Where are we? So that was in there. There's some mucky sort of glue in there, so keeps getting everywhere. That's better. So how does this work? Very simple, in fact. Got a circuit diagram here. Here we are. So we've got the mains voltage coming in here. The current is limited by this capacitor, a 1 microfarad capacitor. What that does, it simply limits the amount of current coming through. It's a bit like, how shall I explain it? This doesn't actually dissipate any heat. If you could put a resistor in there, but it would dissipate quite a lot of heat. The current can't actually get through there, but it can charge it up. So on every half cycle of the mains, some current goes in there and charges up this capacitor. Some more current goes out there and through the LEDs. And on the other half cycle, it goes the other way. So some current goes back again, but no actually current can go straight through there. So basically it limits the amount of current going through. It's not quite like a resistor, but it does limit the current in the same sort of way without dissipating any heat. And if you divide the voltage by the current, you get a value in ohms, which you can calculate from this little formula. Well, it isn't resistance, it's called reactance, because it doesn't dissipate any heat. And the formula for that is 1 over 2 pi fc. F is the mains frequency, 50 hertz. And C is the capacitance, 1 microfarad, so that's 1/1,000,000 of a farad. And that will give you a value here, and plugging the values in, you get 3.18 kiloohms. Now, if you apply 240 volts to 3.18 kiloohms, you get 7.5 milliamps. So the average current going through here will be roughly 7.5 milliamps. Be a bit less than that, actually, because the voltage across here is, I don't know, it's going to be a substantial amount, maybe 70 volts. So it'll be actually 70, 240 minus 70, which you would have to divide into 240. So it's going to be something like 7.5 milliamps, something like that. Okay, so we've also got this resistor, which is simply designed to discharge the capacitor when you unplug it, just for safety. That's quite a high value. It doesn't serve any purpose during the normal running. Then we have this bridge rectifier. Very common little circuit. If you haven't come across this, I'll explain it very quickly. Each of these 4 diodes, they'll only conduct current in one direction, the direction of the little arrow. So when this is positive, the current comes in here, can't go through that way, so it goes through that way, and it goes round there and down through there, through the direction of the LEDs in their arrows, and back through here, coming back to here, then has to go that way through there, can't go there. Anyway, it goes back through there. If that's positive, the current, again, can't go through that way, but it comes through there and goes round here. And again, the same direction round there and back here. This time it goes through that way, through there and back there. So whether that's positive and that's negative, or that's positive and that's negative, the current always goes the same way round there. We then have this little smoothing capacitor. So normally the AC would be going positive to negative like that. On here it'll be just going positive, 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 but it'll be lots of humpy peaks like a mountain range. So basically this stores some of the electric charge in between the peaks just to smooth them out a little bit. Once again, we've got another resistor here just to discharge the capacitor once you unplug it. So that's all there is to it. I've taken some of the components off here, but we've got the two resistors there. The bridge rectifier was on there, and if you turn it over you can see where the two capacitors were. There's one there, I think that was that one, and I think that was that one, yes, because this is an electrolytic, and electrolytics are polar. You must connect them the right way round. So that is the positive up there, and that is the positive. You might just see a plus sign there, and that's the negative. Okay, so that's all there is to it. Not very much to the circuit at all. So what went wrong with this lamp? Well, I tested the two capacitors, that one there and that one there, with my little component tester. I'll show you when I get around to the G4 discs how to actually do that test. And both of those seem to be fine. I tested the 4 diodes in the bridge rectifier, and also, just the 4 diodes in the bridge rectifier with my multimeter, and they seemed fine. And again, I'll show you that when we look at the G4s. I've taken off the bridge rectifier, so I can't actually do that on this one. I needed one of those for some other little project, so I took it off. And I took those capacitors off for ease of testing. So that basically just leaves nothing much to go wrong with the resistors. That just leaves the LEDs. Well, I used my little LED tester to test those. Here we are. And I've got a couple of test leads connected to this. All it consists of is a resistor, USB plug which goes into that power bank, and I've got a couple of test leads and a couple of pins which make it easier to make contact. Now, if you look very carefully, I don't know whether you can see. Let me see if I can focus on this. Is it going to focus? Come on then. Don't be shy. There, you can just see the solder pads at the end on the two sides of each of those little packages. So we ought to be able to get the pins onto those. Right, zoom out again back to where we were. Okay. So we take the pins. We don't know quite which way round it is, but let's try that way round, and we should get that LED to light, but it doesn't. Try that one. There again it doesn't. Try one in the middle of the row. No, that doesn't either. Well, maybe the wrong way round, so let's try the other way. Nothing there. It could be that there's some flux or corrosion or something preventing me making a good contact, but I should be able to get through. These pins are quite sharp. There again, nothing. Well, in fact, that's what I found when I first tested it out. For some reason, all 9 of those LEDs seems to have failed. Don't know quite why that would be. There's some sort of, it's basically a little aluminium heatsink. There's a bit of heatsink paste there, but not an awful lot. And there's a conductive track somehow on the front. There must be an insulating layer, and then the conductive tracks go on top of that, and the little packages are bonded on top of that and soldered on. So quite why all 9 of them should have failed, as they apparently have done, is something of a mystery, but they have. Most likely something to do with overheating. Can't really tell what. But there we are. That's that. Not a lot else that we can do with that. So that was the GU10. And I put up as the background, while I do this wrap up, a picture of the same GU10 in a slightly less destructive state of disassembly. And our conclusion then is that the heatsink probably wasn't sufficient. I thought at first maybe that silvering on the inside of the glass wouldn't help, but in fact it's probably thin enough that infrared can get through it. But even so, there's not much chance for any ventilation. So insufficient heat sinking was probably the cause, though even so, it's not quite clear why all of those LED packages seem to fail. In the same video, I was going to run through the teardown of those 2 G4 discs, but I ran out of storage on my phone, so it's probably as well that I do those in a separate video. They're a slightly more complicated design, but at the same time slightly more interesting. So I hope you'll come back and look out for a follow-up video in which I'll do those, and probably yet another follow-up video in which I'll dismantle and tear down several bayonet 240 volt bulbs, and I've also got another GU10 which I've got to tear down, and a R50 reflector, and we'll see how those go. Okay, thank you for watching this video, and I hope you'll come back and watch the subsequent ones.